Whenever Bang & Olufsen develops a new loudspeaker, our goal in tuning that speaker is to try to ensure that when you're sitting on your sofa in your living room, you hear the same thing from the recording that the recording engineer or the mastering engineer heard in the studio. This is a challenging task, primarily because your living room has a very different acoustical behavior than recording studios. That's mostly because of the way the walls are built and the way they're arranged. In a living room, you have very reflective walls, more than likely, and they're arranged parallel to each other. What that means is that when sound comes out of the loudspeaker, it not only goes to the listening position, but it also heads towards a side wall, a wall on the side of the room, bounces off, and also gets to your listening position, which can infect the sound of the loudspeaker. In a recording studio, things are very different. The side walls are either coated with an absorptive material, which will soak up the sound, or something called a diffusive structure, and what that will do is bounce the sound in all directions. Or they'll be angled differently, so that the sound going towards the sidewall will be angled away from the listening position, and that creates what's called a reflection-free zone. The reason they have that in the recording studio is that they're trying to, as much as possible, hear the reflections that are built into the recording and therefore get the perception of depth and distance inside the recording without being overcome by the reflections in the recording studio, which will make everything sound like it's the same distance. And this is what we're trying to achieve with BeoLab 50 in your living room as well. Basically what we're trying to do is to try to make the beam as narrow as possible. And what that will do is direct sound towards the listening position and send less sound towards your side walls. So although your walls are still reflecting sound, there's less sound sent that way to reflect. It's a bit like making a spotlight and directing it at one position in the room and not worrying about how much light is going to bounce off other surfaces, because it's darker over there anyway. There's less light bouncing off. In addition to trying to make that beam as narrow as possible, we also want to make it as same as possible in all frequency ranges. So we want the bass and the mid-range and the treble to all have the same width. And what that does is it ensures that we don't have a strange sound bouncing off the wall. So if you were to only listen to that reflection coming from the sidewall, you would hear as much bass, as treble, as mid-range. It wouldn't have a strange balance relative to what we're sending out the front. With BeoLab 50, we're controlling the width of that beam in two different ways that work together to do the job. On the lower end, for the woofers and the mid-ranges, we're controlling the beam actively. And what we're doing here is we have 3 woofers and 3 mid-ranges, and each of those has its own amplifier, its own signal processing chain. In essence, it's being controlled by a computer inside the loudspeaker. And each of those drivers, every woofer, every mid-range, so all 6 of them, get their own individual sound. And what we're doing here is we're saying, we'll send sound out towards the front, but we want to reduce the amount of sound that's going out the side. So in some cases, we'll make the woofers or the mid-ranges work against each other. One will be canceling the other in a similar way that noise-canceling headphones work. In another frequency range, where, say, the woofer is automatically beaming by itself naturally, then we don't need to do this, so we'll have less sound coming out of one of the rear woofers, because we don't need to control the width of the beam. That's how we control the beam for the mid-range and the woofers, so the lower section of the speaker. For the high frequencies, we've done things slightly differently. As you can see, we have a tweeter inside an acoustic lens, but this acoustic lens is very different from anything we've made before. Initially, you can see that the shape of the lens is quite different than on our older loudspeakers like the BeoLab 5 or the BeoLab 3. That's because at the moment, the BeoLab 50 is in narrow mode, and so those reflectors on the sides have been angled in more. What that's doing is making the beam narrower and therefore reducing the amount of energy that's being sent towards the sides of the loudspeakers and therefore bouncing off the sidewalls. But we can change the loudspeaker's behavior to be in a wide mode. And when we do that, what will happen is these reflectors will move outwards. and thus making the diffusion or the dispersion of the loudspeaker much wider, giving us a 180-degree spread of sound in the room, which is more designed for sitting on the sofa watching a movie with the family, a more social situation. Although we have an enormous amount of control of how the loudspeaker behaves in space with beam width control, so we can have our narrow or our wide dispersion of the loudspeaker, there are some aspects of the room's acoustics that we can't look after with this beam width control. The first one is how the loudspeaker's low frequency behavior will act as a result of where it's placed relative to the two closest walls, so in our case this side wall and the back wall. Typically what happens with a loudspeaker is that if you push it into the corner, you'll get more bass. And that's because those wall reflections are helping the low frequencies and amplifying them more than they're amplifying the high frequencies. This makes the sound very boomy, and we want to undo that by removing bass from the loudspeaker so that the less bass coming out of the loudspeaker plus the reinforcement of the walls will give you a better sound, you could say. In addition to that, all rooms have something called room modes, which is a resonance or a ringing in the sound of the room. In essence, the air in any listening room will resonate in the same way that a guitar string will resonate or sing, or an organ pipe will sing. And it will sing at the same frequencies as if we had an organ pipe that was the same length as, say, the width or the length or the height of the room. So what we're really listening to is the sound of the loudspeaker, plus maybe a bass boost caused by these close walls, plus these extra frequencies that are ringing along like organ pipes. And we want to undo that effect, or at least reduce the audibility of those effects. So what we do to solve this problem is we include a microphone with the BeoLab 50s, and that microphone is plugged into the back of the loudspeaker, and we can place it around the listening position, say in 3 different locations around the sofa, and we'll do some measurements. The speaker can measure how the speaker itself sounds at that listening position and compare that to what we expect it to sound like. It will then undo that difference. So if it sees too much bass, it will remove some bass. If it sees too much at one frequency, say 165.3 hertz, then it will remove energy at that frequency. In essence, what we're trying to do here is not to change your room's acoustics, but to undo their effect on the sound of the loudspeaker. So we're not doing room correction, we're doing room compensation. Of course, that only works in the area where you've done the measurements, where you've put the microphone when you first set up the loudspeaker. And that may not necessarily be where you want to sit tomorrow. So what you can do is do some measurements, say on the sofa, and call that sofa setting. And then do some more measurements, say in the dining room, and call that dining room setting. And another set of measurements in around a chair, for example, call that chair. And then if you want to just have background music and you want to move around the room, say you're having a party, then you can select all 3 of those sets of measurements that you've done and create a 4th filter. It will generate this new filter that is applied to all of those measurements that you've done, and therefore optimize for the entire listening position, which is the room for the party. Of course, these are a lot of parameters to play with. We have beam width control, either narrow or wide. We have different active room compensation zones that we can mix and match as we see fit. But you don't want to have to play with all of these different controls every day. And of course, there are more controls in the BeoLab 50 that I won't talk about here. So how do we get around this? Well, what we've made are what are called presets. If you make a preset, then what you're doing is assigning a lot of different parameters that are applicable to one listening situation. So let's say you want to make a preset for sitting at home alone on the sofa to listen to music. Then you can set maybe the loudspeaker to narrow mode with a very close zone for the active room compensation and all of the settings that are associated with that activity, sitting by yourself listening to music. You may make a different preset that's for watching a movie alone or watching a movie with your family. You can have a different preset for each of these different activities. And what those will do by recalling the preset is reactivate all of those parameters that you've preset in advance. So you don't need to worry about fiddling with all of these buttons every time you sit down to listen to the loudspeaker. The There are three ways to control those presets. One is with an app, and what you can do is actually use your smartphone or a browser to control the loudspeaker directly. So you can simply call up all of these parameters individually, or you can select your presets directly using your smartphone. Another option, if you don't want to walk around with your smartphone, is to use an infrared remote. So you can use a BeoRemote 1, for example, to talk directly to the loudspeaker if you connect an infrared receiver to the master loudspeaker. And in that case, what you're doing is selecting different presets with the remote according to the parameters that you've already set up in advance. The last way is to use your Bang & Olufsen television. In this case, what you can do is set different speaker groups, which is a normal feature of all Bang & Olufsen televisions. And within that speaker group, you can set a speaker preset. And what's happening there is that the television is telling the loudspeaker, either through PowerLink on the wire or through wireless PowerLink, to change presets to match the parameters that you've set in the television. So you can have, for example, a speaker group for sitting at home listening to music by yourself, and that will automatically recall that preset in the loudspeakers from the television when you select that speaker group. So in this video, we've looked at the beam width control, the active room compensation, and the presets and how to control them. However, there are many more features and parameters that are available in BeoLab 50. Those can be found, and information about them can be found in the technical sound guide, which is available on the support pages at the Bang & Olufsen website.